Good morning, everybody. Go ahead and grab your notebook and grab another coffee. We're going to get started here in a couple minutes as the last few people start trickling in to the webinar. So we'll get started here in a couple minutes. All right, good morning, everybody. Thank you for joining in on this month's webinar. As you guys got my email yesterday, had a little difficulty with our brand new website getting the event back up and running from our old website. So thank you for pivoting and joining in today. We got a couple topics today that I want to cover. First thing I want to talk about though is I'm seeing some of you join and subscribe to our YouTube channel. We started a metrology training channel where I take all these webinars, I load them on there, and we're going to be bringing you more information onto that YouTube channel, some hand gauge training and some other things that you guys have requested. So hopefully that'll be a nice resource for you guys. So feel free to go to YouTube, and if you just search ATI Metrology Training or channel, it'll pop up there. A couple other MicroView videos on there as well. Also, I want to talk about upcoming events. We have the Quality Show coming up in a week and a half or so, October 26th through the 28th. We'll be at there with a few other machines, and the metrology training seminar in Warsaw. We had that back in July in Warsaw for all of our Indiana customers. So we're going to be bringing it back 3 days. So the Quality Show will be in booth 1719. You can see the show hours here. You guys can register for free if you go to our website, atiquality.com. and you go to the events calendar, you'll see that to register for free, you'll get our VIP code to attend. We'll have a bunch of equipment there. We'll have a couple of the microviews. We'll have a Vici vision system, really good, like a shaft scanner. We'll have the Mitutoyo Shop 4 CMM, the MyStar. We got an Oasis machine and EvoCam from Vision Engineering. And the floor at the quality show is awesome. You can see all the different distributors of measurement machines and all the fixturing out there. It's actually really cool to attend. I always like taking time to walk the floor a couple times to see what's going on there. And you guys will be able to hear about our brand new website and a new platform we have going on there. Like I said, we're bringing the Metrology training seminar back to Warsaw. Day 1, we'll be talking about hand gauge training and blueprint reading. Day 2, we'll be going through our basic and advanced microview class, and then our new class of programming and reporting GD&T with microview. You can attend one day, all days. Email training at atiquality.com for more information. It's a really good time, 3 days of learning, and all the questions that you guys bring to the seminar actually helps myself learn some new things too, so I really enjoy it. So if you want more information on the quality show or the training seminar, email training at atiquality.com. It'll go to Dan and myself, and we'll be able to answer any questions you have there. All right, so August webinar. Sorry we had to skip September. It just got crazy in the inspection department. But back in August, we talked about the rectangle tool and different uses for the rectangle tool, even reporting true position from the center point of the rectangle tool. We also talked about using calculator functions to export absolute results. So you can see here when you do an origin to the center of the part, you have your negative X, positive Y, all the locations, but when you're reporting true position or some other dimensions that you want, we can use the calculator function to be able to convert those negative results into positive results for your reporting. And I'll actually show you, we're going to be talking about proper skewing today to align your part. And this might help with some of you that have a wrong skew or a wrong origin and all your numbers are negative. So hopefully the skewing will help you there. We also talked about offsetting features and construction features. So if we wanted a certain diameter at a certain height of the cone, we learned how to do that. And also the importance of leveling. So we see on these two different diameters going on here, not leveled and leveled, what happens the way you measure them if you don't level to a certain plane. So these are all on the recording. You can email myself and I can send you the recording, or you can go to that YouTube channel and it is on there. Cool. Before we jump into the October webinar topics, as a reminder, we have the chat box. If this is one of your first times, there's a chat box. You can pop any questions in there. Dan will be able to answer them on the fly, and if he's not, we'll have time at the end to maybe do them live, or we'll follow up with you. So the topics that I want to talk about today are text fillers within your programs. If there's any dimensions that you're not measuring on the part with the microview, but you're exporting to Excel, it's kind of annoying to copy half of the Excel sheet and then copy the other half. I'll show you what I'm talking about there. Proper skewing. If you've gone through our basic training course, you've seen that when we do the basic programming slide, we tell you to skew X to the bottom line. I'm going to show you reasons when to do that and actually reasons why not to do that to help prevent some of your systems flipping. I want to talk about storing systems. There's a lot going on there. I'll get more into detail there. And then working with DXFs. We've imported DXFs on these webinars before. We've adjusted and we've programmed offline with DXFs. But I want to show you a couple tips and tricks within settings that you might not be even utilizing to your advantage. So here with text fillers, if you are using the microview for, let's say, half your dimensions or all but a couple dimensions, when I export to Excel in column B, I have all my actuals that I'll copy and paste to my official inspection report. But it always kind of annoyed me that if I was going to do some caliper measurements, or I needed to put it on a roundness tester or a con tracer or whatever it might be, I always had to copy half of the Excel sheet, paste it, and then go to the next form and copy and paste it. What I started doing is inputting text. So if you do the A without a question mark, the text, and you label it whatever dimension you have going on, but you leave the text blank, and then you can export that text. It'll leave a blank spot in your export to your Excel. So let's go ahead and jump over to inspect here. So I've got this program that I ran. I can move over here and show you the actual part so you guys see what's going on. Let's get that guy in focus. So I got this little either headlight connector or whatever it might be. I have all my pin 1, pin 2, pin 3, and all these other dimensions going on here. But if I was going to measure the ID, let's say with a caliper or with a CMM or whatever it might be, or maybe dimension after that, in my program, I would click text. I would leave this blank because this is what's going to export to the B column. Click OK, and you can either right-click rename or hit the F2 button if you like hotkeys. You know, we call this dimension, let's say dimension 10. Click OK. And then if we hit F4 or right-click export, I can export the text and labels, leave it all blank, and then when we go to our Excel sheet, we will see it pop up like this, where there is blank cells in the B column. So then you can go in and you can type in your caliper measurements or whatever it might be, or when you copy and paste it to your Excel sheet. So it's just a little trick that I've been using to still fill out my full report and get all the dimensions I need, especially if you're translating. Figuring out where those dimensions are can be a little frustrating. So hopefully that's useful for you guys. If you guys use the text input for any other sorts of tips or tricks like this, I'd love to hear about it. Let's talk about proper skewing. So skewing, normally if we have, I'm going to use the practice slide here that you guys are all familiar with. If your part is within 45 degrees of your X direction or your Y direction, and you hit skew and you just click that line, MicroView is going to know which direction it is. And when you're programming, however you have that part within that 45 degrees of X or 45 degrees of Y, you need to place that part in the same location every single time. Or not in the same location, sorry. You need to place it within 45 degrees of that location on there. When we teach you in the basic training class, I'm going to come over and find my practice slide here. Get this guy in focus. So a common system that we use is line-line intersection point. So I'll find the corner of this part. I'm going to select line, F-scan line, F-scan line, and now I'm going to do a point of intersection between those two lines. So when I'm creating a system, the three most important things that you need, just as a review and for our first-time users, is you need an origin of X and Y, an origin of Z, and a skew. So right now I have my intersection point that will be my origin of X and Y. I'm going to do my focus point. So now I have my origin of X and Y and then my origin of Z feature. And then I already have my bottom line that is going to be my origin of, or my skew. So in our training manual, we'll have you go origin, deselect Z, select our intersection point, origin of Z, select our focus point. And it's nice that MicroView grays out all the features, but it still has skew, almost like it's like, hey, I still need this. So if I click skew and you click X and we click this bottom line, it matters if you click left or right, left to right with your F-scan line. If you don't select X and you just say skew to this bottom line, if that bottom line is within 45 degrees of my X direction, it knows that's my skew in X for that, and it'll apply it. Same thing with Y. I was just recently at a customer, and for some reason, I always lean towards skewing to X, but all their programs, they skew Y. So whichever one, you can apply it for Y or X going on here. So now I can skew to that bottom line. And down here, you can see skewing to line 2. So I want to show you what happens if I just do skew X to this bottom line. When I originally programmed this line at the bottom, I clicked left to right. So now if I run the program, I'll do my first line, I'll hit continue, I'll do my bottom line, hit continue, put my focus point, hit continue, and our origin stayed the right direction, our part's all good, our program will run fine. Now if I run the program again and say Dan wrote this program and now I'm running the program and I don't know how he ran the program or wrote the program, and I like doing right to left, when I hit continue, it flips my origin because I went right to left and Dan programmed it left to right. So now all of a sudden my program's totally reversed and my program won't run. I'm going to go ahead and delete that skew. Now if I click skew, I don't select X or Y. When I run the program, do my focus point, my origin stays the same. So if you have many operators and many programmers, I would highly recommend not clicking skew X or skew Y if you're able to. Within, if you have two weird skews on a really weird print, I totally understand that, and you have to skew X and Y. But if you don't have to, this helps you prevent the origin from flipping on there. And another thing too is that if you measure, I had a customer that was measuring with touch probe, and the only way they were able to quickly program was to take their points from right to left, and then when they skewed X to that, it flips the whole program. So if that's the only option you have to make quicker programming, if you're really in a bind to program the quickest way possible, their origin was always negative. So their whole part, that was all their measuring features, were all negative numbers in negative directions. So what I told them to do was to go delete their skew, because they had skew X, and just apply the skew to that line. And now it doesn't matter that they go right to left, because their origin will be flipped and all their numbers will be positive in this direction. Now what I mean by that, in case that's confusing, is if I skewed X to this line, since my origin, and I'll go back to the other slide here in a second, since my origin, this is positive in X going to the left instead of the right, and my positive Y is going towards me, towards the front of the machine, so everything below it is negative Y. So all these diameters, an F-scan circle here, my center X and Y are negative numbers. And sometimes if you're just copying and pasting out of the Excel sheet, you don't want negative numbers, you want absolute numbers. And it's frustrating for them because they have to go and formulate all the absolute numbers with the calculator, but now since you just skew without clicking X or Y, they're able to do that. So if you guys have existing programs, save a copy of your existing program in case something doesn't work, you're not ruining the program. Go in, delete that skew X, click skew, don't select X or Y, click that line, and now all your numbers should be positive on there. So again, just remember, however you program your part, you want your line, if you're skewing in X or skewing in Y, to be 45 degrees within the machine X or Y. And when you run the program, you want to do the same thing on there. So if you guys have any questions about that, feel free to pop those in the chat box or send us an email and we'll get back to you. All right, so now I want to talk about storing systems and common applications for storing features. We can store stage square locations, fixture plates. We can store datums to recall later. We can store features, maybe planes on the glass. So I'm going to show you these things. And also, I'm going to show you, once you store a feature, if you get a new stage square or new glass, how to update those stored features. So here's an example, is we have this stage square that we custom made for a customer that we want to save the location of this stage square, so the theoretical intersection point of these two lines, because when we take this stage square off and put on another one and then bring this back, we know it's not going to be in the same exact location. Same thing with your machines, is that you want to store this feature, store the stage square feature, because when our calibration techs come, and if they have to remove the stage square for any reason, or if you get new glass, your programs will follow this stage square recall feature. And then when you get the calibration or new glass, you update the stage square location and it'll update your programs on there. So I'm going to start here, jump over to InSpec. So I got this stage square that comes with, if you buy a new machine, it comes with it. A lot of you probably purchased it with your Generation 2 machine. If you don't have a stage square and you would find it being useful to have one, let us know. So here I'm on the Y-axis. I'm going to go ahead and do a new program. So if you don't have any stored features, when you hit the recall button, you're going to just see the recall reference system, which is your machine 00, and that's what makes programs fully automated. At some point, we have fixture 23, datum A, whatever that might be. I might have done that in a previous webinar. So I'm going to go ahead and measure my stage square. I'm down to the corner here. Get more inputs. Come over to my X direction, do a new line. Down a little further. Do an intersection point between the two. And I forgot to make this fully automated, so I'm going to right click on my first feature. I'm going to say insert here. I'm going to do my recall reference system. Insert at end. I'm going to highlight the features, right click, set system, my system 4, so now it's fully automated. So now I'm going to set my origin to the intersection point, and I'm going to skew to the bottom line. And you can make this a little more better by doing a focus point on your stage square, or whatever it might be. Now I'm going to right click that system. I'm going to rename it here. Stage square. So I'll right click my stage square system and I'm going to go to store. And I want to save this permanently. And this is going to store back in some folder deep within your C drive. It should be where you can go and you could delete some of these stored systems if you have them, if you have too many or ones that you're not going to use anymore. We can cover that on another time, but I'm going to save this permanently. So now when I go write a program, one mistake that I just made is I should have saved that program. I'm going to redo that real quick here for you. Sorry about that. Let's go ahead and remeasure this and actually save that program, because we want to save that program in case our stage square moves. We want to be able to rerun that program to update that stored system. I do this line, more inputs, measure this line. It'd probably be a good idea to clean your stage square, like all that junk. We want to get that off of there. Measure this, come down, do an intersection point again. I want to do my origin, the intersection point, skew to my bottom edge, stage square, like it's cell. Okay, and we'll right click on that system, store it, save permanently, click OK. I want to overwrite it. Now I want to save this program. And you could save this program in a safe location that you'll be able to access later to rerun this. All right, save it. Now I'm good. So now I'm going to go write my programs. I'm going to put my part back on the stage. Now I'm going to recall, instead of recalling my reference system, I'm going to recall my stage square. So I still got a fully automated program, but it's referencing my stage square, not my machine 00. And then we can go and measure our part. So now, let's say that you move the stage square. I'm not going to bore you guys by taking the stage square off and putting it back on, but say that you moved your stage square and our stage square isn't in the same location anymore, which means that our parts aren't going to be in the same location anymore. What I would do is I would come to my stage square, I'd rerun this program, and since it's in the same location, it's going to hit the lines, but let's pretend that it doesn't hit the lines, which that's good right there because I have the part in the way. So now I would come over here, fix my tools. So if I move the stage square and it was over here and it's failed to measure, I would just move my tools, run the rest of the program. And then now what you have to do is save your program, because you want to save the new location, and you also want to store the feature again. And I want to do both. I've seen, it's a little wacky that I've seen on my generation 2. All I have to do is rerun the program and it updates everything and save it. But I always just in case, I go back and I store the system again so I can reference it, just to be safe, and you did your job and it's all good there. So that's one thing that you might want to store. Other things that we can store are fixture plates. So if you store your stage square, that's good because your fixture plates are butting up against your stage square. Your fixture goes there and they magnet onto there. But you also might want to really bulletproof your programs by maybe saving the locations of a pocket fixture that you have, or locations of a certain place on your fixture. So in this case, if I wanted to store this location on my fixture plate, but then for some reason I start using touch probe and I can't reach over to this location, I can update my fixture location to this pocket, so my whole program over here will move over here. So that's another thing too, is that you could do line, intersection point on this pocket. You could do it on this pocket. If you have other features on your fixture, maybe that's a more custom fixture, that you've made or we've designed for you. It's always good to store your stage square system, and it's good to store your fixture plate system, just in case you use this fixture plate all the time. You start scratching up all the acrylic plates. You guys want to make a new one. As we all know, there's no perfect part or perfect manufacturing process. The fixtures might be a little bit different. Then you can go in and update your systems and resave them permanently, and it'll update your program. Now, another thing that I like to do is if you have fixturing like these posts here, if I'm fixturing my part onto these posts and my part is sitting on datum A, so datum A is contacting these 3 posts right here, I can measure a plane off of these 3 posts, store that system, and then recall that, because once you put the part onto the fixture, you're not able to measure those. And also, in some cases, if you measure the plane in the beginning of your program and then you put a prompt in to say place part onto the fixture, that's just an extra step that you have to do. So what I like to do, let me switch over to inspect. I'm going to switch out my fixture plate to posts that are similar to the ones that you just saw on the slideshow. Now I'm going to turn on surface light so I can see my posts. I'm going to move over here. Sometimes the hardest part is finding the location, isn't it? So I'm going to go ahead and create a plane. It's datum A. I'm going to do more than 3 inputs. Since you're not going to have to run this every single time on your program, because it's going to be a stored feature that it's just going to recall, you can go not overboard, I'd say, but you could do 3 points on each post just to really ensure that you're measuring datum A correctly. I'm going to take a couple more focus points here. Now, ideally, these fixture posts, they've been beat up. We've used them for years. If you're going to do this, where you're going to set datum A onto these, you might want to have like a nice machine controlled surface that you're placing them onto there, whatever it might be. So same thing, just like as that system, we can store features. I'm going to rename this guy datum A for part 1, 2, 3. And I'll right click that feature, store system, save it permanently. And again, you can save this program in a safe location. So datum A, part 1, 2, 3. And now when we go to create a new program, we can recall our stage square. So it makes it fully automated in relation to our stage square. Then I can recall datum A. So there it is. And it's going to recall it. It's not going to have to measure it. And then you can go on with your program and measure everything. And then you can reference features to datum A, even though you can't physically see it because your part is on top of those posts there. So that could be useful, or if you have a fixture that kind of clamps down your part and you have an alignment that's underneath your part when you clamp it in, this might be a useful thing. So best piece of advice I'd say for trying something like this for the first time is try it out, do a study, make sure that you are getting the results you want. Sometimes since you are storing features to a fixture and the fixture might have a better tolerance that it was made with, that you're getting too good of results on your, say, plastic parts, just have that caution and make sure that what you're storing and what you're reporting is accurate and works for your process on there. So I also did this if you are measuring multiple parts on a pocket fixture like this. I went and I stored each pocket plane off the glass. Because if I'm placing data may onto the glass and I need like an overall height, for example, on these parts here, if I need an overall height from the glass that data may is sitting on to the top of the part, it was really nice to be able to just recall each one of these planes off of each pocket fixture and do that. So if you use this pocket fixture for multiple part numbers, all you have to do is store the planes once because it's your glass, and then recall it for whatever feature you have or whatever part you have in each pocket. Again, save the program. If you get a new piece of glass or when our calibration tech comes out to your location to calibrate your microview, if they re-level the glass, if it's unlevel, so you want to rerun all these programs just in case. Hopefully that spurred up some ideas for you guys. If you guys have any challenging fixtures that you guys are making in-house, or if we've designed them for you and you'd like some more advice on them, feel free to reach out to us. We'd love to help. So now let's talk about importing a DXF. We've talked about importing DXFs before, how to bring them into your inspect software, how to program offline with them. But I kind of want to get into a little detail of the different tools that are created. So basically, in the big scheme of things, is when you import a DXF file into microview inspect software, it's converting the lines that you designed or your engineer designed into measurable features using microview scanning tools or best edge points, whatever it might be. So if we go to inspect, then go to file new. So if you guys want to practice importing DXFs, you all have the good old practice slide. If we go to C drive, x86, we go down to Microview Corporation, inspect for Windows, and it'll either be at the bottom of this folder, you'll find the DXF files, or if you go, I've seen with the new generation machines, it's on the samples folder, and I'll open up the sample DXF. So the first thing that pops up is this window. If Dan or I have been at your location to train, we've done advanced training, we've probably switched these options for you. But what we think is best doesn't mean it's the best for your part. So if you want to change something, or if we haven't been out there, you can go ahead and you can go change these. Now, this is a global change, so when you change it once, it's going to do it for any future DXFs that you import. So if you have multiple programmers, or if you have multiple operators, whatever it might be, you might want to get together as a quality team or engineering team, production team, and decide on what you want these tools to do and which ones to use. So there's two major fields here that we want to make sure that we're selecting the right ones. If when you import a DXF, and if the camera window, the field of view, can see the whole diameter, these are the tools that it's going to use for a circle or a line, whatever it might be. I always recommend using F-scan tools just because they're on the more repeatable side, say 80% of the time that I've seen, instead of using best edge points. And also too, it's faster, it runs faster in the program. Circle, same thing. You could do best edge points or F-scan circles, so you can select whatever you'd like in here. I would recommend, if you're more of a best edge programmer, use best edge or F-scan. Don't use closed profile or profile circle. I don't see a lot of repeatability with these two features, with these two tools here. So you can go through and you can choose what you want for each one of these. Splines, if it imports as a spline, open and closed, you're going to do follow open, follow closed. You can switch it to F-scan arc or F-scan line on the open spline, but hopefully when you're importing a DXF, you're not going to be getting any splines there. Now down here, for any features that are larger than the field of view, so like this outer diameter that you see here in my camera window, it's going to need to use best edge. We don't want to use follow open, because follow open, if you have any scratches on your glass or any fixturing, it could follow those and you won't get any good readings. Next to those are how many best edge points make up that line, circle, arc, ellipse, rectangle, whatever it might be. Now, if I'm doing an F-scan, or if I'm doing a best edge line, I would, 2 points make a perfect line. You're not getting any straightness. So minimum, I would say have 3 best edge points for a line. Now, this is where I was saying that you might want to get together as a team and decide, all right, we want our lines to be at least 4 or 5 points. We want our circles to be at least 6 best edge points, so you're really getting the shape of that diameter. And this also might be something that you need to consult your customer, that if they're measuring their parts with a microview, or if they're measuring it with like a Metrology CMM and they're taking 8 to 10 points, you might want to match what they're doing as the same. Now, the one frustrating thing is that if you're running a semi-automated program and we have 10 points for a circle, and that circle is our origin that we're locating the part, you're going to physically have to go click those 10 points, but the rest of the program will run those automated for you. Arc, I would recommend at least 4 or 5 for the arc when you're importing it, and then so on. I know out of 2,500 microviews that are in the Chicagoland area, I've had 2 customers in the past couple of years that have to measure ellipses, but just decide how many points you want for all these. Now, as we talked about rectangles back in August, I like importing the rectangles as 4 separate line features, so I can use those lines for other measurements. If it imports it just as a rectangle, it's still going to use best edge or F-scan lines to measure those lines, but that rectangle is going to be tied to itself, and you can't use those lines for maybe a distance to a diameter, distance to the outside of the part. So I like clicking that one on there. Now down here. So if you guys open up this box on your Generation 2 machine, it will be, actually, if any machine that you open up, it'll be defaulted to 24 pixels. And basically what this is when there's a best edge tool, it's going to be, on a Gen 2 machine, it's going to be a good size best edge tool or an F-scan line. Basically, it's that guard band, those dashed lines whenever you put any of the vision tools, how big it's going to be. Gen 3 machines can see 4 times as many pixels in the same area as a Gen 2 machine, because the cameras are upgraded on the Generation 3 machines that came out last year. So on the Generation 3 machines, we need to be jumping those up to about 125, because 24 pixels is a very, very small best edge point when you import a DXF on a Generation 3 machine. But if you're happy with the 24 on your Generation 2 machine, you can leave it. But if you want those tools to get bigger instead of being that size, feel free to go in and try out, see what 100 pixels looks like on your Generation 2. Feel free to go in and just see what those sizes look like to get the best scanning for that on there. So I'm going to show you, if I bring in on a Generation 2 machine, what 24 pixels looks like. So we got our handy dandy practice slide here. Let's put that back on my stage. So I'm going to set my intersection point. I'm going to set my origin to that intersection point, and I'm going to skew that line. Next, find it. Now I'm going a little fast through importing a DXF here. Like I said, we've done that in the past. If you want some help importing a DXF, feel free to reach out or go into your advanced training manual, and you'll be able to find all these steps that I'm kind of flying through here. And now I'm going to run my program. Now when I click this tool, I did 24 pixels, and can you guys see how small that tool is right there? Because this Gen 3 machine can see 24 pixels within that. On a Generation 2 or 1 machine, that's about 24 pixels on your Generation 2 machine. So 24 is a good size for Gen 2. For Gen 3, we're going to be missing all of our points using that. I'm going to come in, I'm going to re-import the DXF and show you what happens when I change the pixel size. I'll go into that little tools menu. I'm going to jump it up to 100 pixels. Click OK. I do my intersection point. Set my origin. Skew. Notice I'm not clicking X. Next. Finish. And now when I run it, see how my tool, as soon as I click it, I didn't adjust it. That's 100 pixels that it can see in that best edge one. So on a Generation 3 machine, I actually might bump it up to 150 to get maybe a best edge about that size going on. So go ahead and play with it, see what's easier, because if you're importing a DXF and maybe you're making gaskets that have 10 thou tolerances on it, so your part could actually be here and all your tools are failing to measure, it could be helpful to make your search area a little larger. But make sure you don't make it too big, because it could fault out on you and not know what edge it's trying to get on there. So find a nice, comfortable size that you're looking for, and then from then on out, use that as your pixel size, your search area size for your DXFs on there. So that's all I got for you today. Just a reminder, quality shows coming up the 26th through the 28th. Go to our website, atiquality.com, select the events, drop down, go to the calendar. You can register on there. If you have any difficulty finding that or whatever, feel free to contact us. We'd love to help you out to get registered. Or if you are already attending, find us at booth 1719. And when you guys come to the quality show, make sure you come say hello to Ryan, myself, your local sales rep, Dan. We'll all be there all 3 days. Come check out the other equipment that we have. And I was actually talking to a customer this last Friday that they're having difficulty understanding what their customer is using to measure their parts. So if your customer has a Mitutoyo vision machine and you have a MicroView, it is kind of nice to go through the quality show, see all the different vendors, see the different equipment that's out there, so you get a little more familiar with what's going on, and see all the different ways to basically get the same results, but different softwares, different machines. It'd be really good to see. Warsaw training, like I said at the beginning of this, we'll be back down there in November. Email us with any questions that you have if you want to register. I'd love to have you guys out for that. And then we have some time left over. Me and Dan will stay here for a little while. If you guys have any questions, I saw some pop in the chat box. It looked like there was some response going on there. But pop any questions into there, and if I have any samples that I can help you out there, or if you want to see me do anything that I covered today again, I'd be glad to do that for you. If not, thanks for joining today. Check out the YouTube channel, everything going on there. If your quality team is facing any challenges with hand gauge training, blueprint reading, anything like that, we're here to help you guys out. As we're, it's crazy to think we're almost halfway through October. And then, I was looking at November and it's like, wow, it's almost the end of the year. The holidays are coming. We finally got a 60-degree day here in Chicago. I'm enjoying the cooler weather, and hopefully you guys are too. So we'll stick around here for a little bit. hop in any questions. But again, thank you guys for attending, and we will see you next time.